Hello, I'm John Nightingale, a director at JCT and the Symposium host. Now, the 25th JCT Traffic Signal Symposium was an online event this year, and I'm delighted to bring you a recording of one of the presentations. Now, these recordings would not have been possible without the support of a select group of our event partners. So our thanks go to the Institute of Highway Engineers, ITS UK, keepadistance.co.uk, Siemens Mobility, TWM, and of course, our media partner, Highways News. Please check out their short videos, which will tell you about some of the products and services that they can provide. Now, I hope you enjoy this presentation, and we would love to see you in person for our 25th anniversary event in Nottingham Trent University in September 2021. Hope you enjoy it. Thanks.
Thank you, Paul. So I'm Peter Simpson, and thank you everyone, and good afternoon, and thank you for the invitation to talk and to present to you. And just to add, as a keen cyclist and one of those funny looking blokes in Lycra, I really found the previous presentation really interesting and informative. So thanks to Lawrence and Alex for that. So you've got a bit of a treble act from us, and hopefully we'll give you good value for money. We're going to be sharing with you Hertfordshire's approach to life cycle modelling and planning for ITS, Intelligent Transport Systems and traffic signals. We'll take you through a bit of background, some context, our approach, toolkits, inputs, process, outputs, and then finally finishing with outcomes and future. So on this slide, just to put Hertfordshire on the map there, just a few facts and figures for you. Population of around 1 million people, highly densely populated area. A lot of through traffic, all of that adds up to a very busy network. On top of that, over the next 10 to 15 years, growth in population, houses, hopefully jobs as well. Total council budget for the financial year, current year, £860 million, significant amount of money to manage all council services, including highways and transportation. Just to put the network into some sort of context, we've got about 5,300 kilometres of footways and cycleways, 5,100 kilometres of carriageways, 110,000 street lights, and around 682 traffic signals. And the bottom left picture there, that's a photograph or picture of our integrated transport control centre. We're very proud of that, and one of the few local authorities to have one of those. And that helps us to manage and monitor our intelligent transport systems, including all those traffic signals across the county. If you go to the next slide, please, Peter. So a bit of context for you in terms of reference. All should be familiar with the various acts, Highways Act, Traffic Management Act, codes of practice and good practice guides and industry best practice regarding asset management and maintaining a vital asset. And the key to that in terms of the golden thread is the life cycle planning, the approach to maintenance from construction to disposal. But it's also a bit more than that. It's about the prediction of future performance based on investment scenarios and strategies. Next slide, please, Peter. So our approach and governance, it straddles the strategic, technical and operational levels. Within our management and maintenance regime, we have a blend of planned, responsive and reactive maintenance. And within Hertfordshire, that operates from top down at a corporate level. Our local transport plan number 4, our highway infrastructure asset management plan. We are one of the first authorities to actually have a transport asset management plan in the country. Our highway services term contract annual plan, and then beneath that we have our operational services plans. We have a suite of performance management, levels of service, risk management, highway fault reporting, and our own defect management approach, all aligned to the national codes of practice, such as well-managed highway infrastructure. What have we got in terms of intelligent transport systems? Predominantly 682 traffic signals, a number of junctions, 208, and about 474 at crossings. In addition to that, zebra crossings, vehicle actuated signs, variable message signs, real-time information signs, school crossing patrol signs, car park signs, cameras and counters, and a whole range of other electric equipment out there. So it's very important to understand what you've got, where it is, the age, but also the condition of what you've got. Next slide, please. I'll hand over to Chris.
Thanks, Peter. So firstly, I will just say toolkits. There are other toolkits out there that are available, but we found that in order to meet the requirements of the various documents Peter mentioned earlier, we needed to get something together that was cost effective and would do what we needed. As we were using IMTRAC for our fault management system, and we already had our inventory, our inspections, faults, energy, site information on there. It seemed like a good place to start to see if that couldn't be developed to give us our life cycle modelling and planning tools. So we spoke to Peter Routledge at Ian Routledge Consultancy and explained what we required, and Peter came up with an offering which he will briefly go through some of the functionality of now.
Right. Hello, everyone. It's a shame, obviously, not to see you all in the flesh, but from the participants, it's a lovely number of people. So really excited to talk to you about what we did for Chris and Peter in Hertfordshire. This is the dry part, but you need to understand the detail to get to the interesting outputs that we produced at the end. So what we essentially built was a tool that took the condition of the asset, basically, and its age and its target lifespan, and then was able to degrade it whilst also looking at scenarios how it could be refurbished and kept up to date based on available funding. So in order to do this, this required a number of parameters. So I'm going to talk through these under the block of the inputs part. So it is on the slide, but I said the upper year, we're doing it a cycle over 15 years. In terms of objective, there are two core ones when we started, which were maintenance spending on condition. This essentially is how much money do you have per year to refurbish the assets, so not spending sort of as run-of-the-mill RTCs, but actually upgrading the sites. And so in this objective, the system will attempt to spend the money each year upgrading what it determines to be the worst sites. The other objective was, if we take money off the table for a moment, how much would it cost me, rather than knowing what I've got, in order to be able to keep my assets at no worse than a given condition. One of the caveats on this is it's currently based on averages, and we'll touch on towards the end the elements we're looking at for going forward and where it could be expanded, evolved and adapted. The simple generation is that we're going to use the values defined in this sheet, and they're going to be global. So each year there's going to be £500,000 available. Inflation's pegged at 2%. We could, however, if I jump forward, we could say I want a granular one, so you could change the available money per year, what inflation sat at, and the cost multiplier value, which I'll touch on in a moment. The idea for this was you could model a capital drop in, say, year 10 of what happened if I put £10 million in at this point in time and see the impact. The cost multiplier is quite simply, when you touch something, to put it back, it inevitably always costs you more money, particularly as on some of the sites, the information we have are, it might be a 2-pole Pelican, 4-pole far-sided toucan. So when you were putting it back, you'd likely be doing more work. So what happens here is, if the raw value for installation cost was 10,000, using a multiplier of 1.5, it would be 15,000 when the calculations were taking place. Rollover budget and applying inflation was, in a perfect world, everyone's maintenance budget would be inflation linked. In hindsight, what tends to happen is you just roll over from last year and you keep getting what you get. The final slider, or the final input on this part, being the minimum condition. If you were in a fantastic world where all your equipment was in a good condition, this prevents the equipment being refurbished too soon. Just because you've got money to spend and it's only a 2-pole puffin, say, you shouldn't do it just because you can afford to do it. Done that one. Right, this bit, and I apologize, this makes perfect sense in my head. So I'm hoping Chris or Peter will step in if I go completely off piste with it. But the gist of it is, in order to degrade the asset's condition, we need to know its target lifespan. So if we were to say a steel pole has a life cycle of 15 years, we need to understand how we're going to move to degrade from when it was excellent when it was installed through to looking in a lot worse condition come year 15. So the way that condition is managed in IMTRAC is that we have a scale that goes from 1 failing through to excellent at 100, and you can then have up to the 98 condition stops between those 2 points, but typically good is 75, average is 50, poor is 25. So what that then means is, if we know we've got the 100-point scale over 15 years, that means the asset will drop 6.67 points of condition per year to go from being excellent in year 1 to failing in 15. But as I'm sure you all know, components do not degrade in a linear fashion. So what these random degradation components allow you to do is, when it's switched on, every time it performs an asset degradation calculation, i.e. where it would lop the 6.67 points of condition off, it will find a random number between these two, and it will then multiply that value between the value that's brought up. So it could be as low as half. So the loss of condition in a given year could be as low as 4, or it could be as high as 9, just to try and inject a bit more randomness to it. Equally, we found it's a really neat way, if you factored them both to be 2, ergo it will always pick 2 as the random number, that you will then have an easy way to sweat the asset and attempt to see, well, what happens if I try and make everything last for twice as long as I'm currently working to. So that'll come out in a bit, I'll show you shortly. The final one in this section of the null sockets pole quantity is, if a pole is not in a retention socket, we assume that when it's upgraded, it will be. One of the things that came back as part of sort of feedback and using the tool from when Peter and Chris had run it in year 1 is that we needed to have a mechanism to exclude sites when you were running the process, because you might have a year's worth of committed funding, but you haven't yet spent it. So if you ran the tool, you'd be including sites that you knew you already had allocated funding for. So that was a really good bit of feedback that came out of doing the process. Growth. Peter touched earlier on in the presentation about growth in Hertfordshire. As we all know, growth is, well, the world's changed a lot in the last 9 months. It'll change again. And we also have the part of who knows what's going to happen in 5, 10. As the further we project, the less certain the world becomes. It's quite simply at this time, growth in the modelling is, you set a ceiling number. Each year, the process will pick a random number between 0 and the value specified. It will then clone that many sites at random and reinitialize the age and condition parameters to try and replicate the stock that's currently available within the area. And I think I'm handing back over to Chris to talk over how all those inputs factor into the Hertfordshire processes.
Yeah, thank you. Right, so the process obviously was get your data, define what you need, your parameters, treatments, costs, everything. Consider the strategies that you want to apply, performance targets, managing risk, everything. Select your deterioration profiles. As Peter explained, we can look at how things deteriorate over the cycle, and we can account for that in it. And then select the scenarios that you want to do. For us, you know, there's a do nothing, do minimum, current investment, more investment, and looking at the outputs from that to see where we go. So Peter, if you can just run the next slide. Thank you. These are 2 scenarios. One is if we were to spend just over £500,000 a year on refurbishment. In year 1, everything looks quite rosy, but as we go on over the years, you can see that we're not investing enough, and we're starting to get sites into the failing, the red category. Whereas if we were to spend £1.5 million over the 15 years. We're sort of maintaining the status quo, and we're keeping above the sort of like the failing line. And could we run to the next slide, please? So here it's a similar thing with comparisons of different scenarios. Here we've got, it's not very clear, but there are 4 lines on the graph, the lower line being the current spend profile, the next one up being, well, these are just increasing in the spend. It's going from $500,000, 1 million, 1.5, 2 million. And from this, we can see that if we were to invest 1.5 million a year, over the 15 years that we're looking forward, we are maintaining everything on an average above the good condition. So this then, going back to my client Peter Simpson, gives him the ammunition when he's doing his bids to try and get the funds for us to deliver more on the refurbishment side. So next slide, I think, please, Peter. And I believe that is over to you, Peter Simpson again.
Thanks, Chris. So just to add what Chris just said, that previous slide in terms of that graph, we actually embedded that within our capital bid, and that was such a powerful tool for us to explain to senior members and management the scenarios and implications for the various strategies and that steady state, the good condition. We've used those types of tools and graphs for a number of years on our carriageway deterioration modelling. So we knew that it was a well-rehearsed argument, and what this tool and graph in terms of the outputs provided, as I say, is really strong, robust evidence to support what we're bidding for, especially when, you know, financial climate as such, and we're having to compete with other council services. So it's really important. And the outcomes for us is that we've had senior member and officer buy-in, supporting long-term investment decisions, supporting budget decisions and allocations. And this year, obviously, because we've used the tool, we've actually received 3 times the level of investment that we had in the previous year, which effectively means rather than doing around 20 sites per year, we're doing around 60 to 70 sites per year, which is exactly where we want to be. So it needs to be affordable, it needs to be prioritised, and it needs to be optimised. It also needs to be sustainable and affordable. Operationally, it's increased our understanding of the network and its performance. It's data-driven inspections and the effective use of the asset condition, and it highlights the maintenance regime and delivery. The other important point is also to explain that if we weren't to have this level of investment, then it's also about cost avoided, because we would see an increase in our emergency revenue type responses. So again, that's a very important point to actually put across in terms of what the implications if we don't receive a certain level of investment. The other aspect is that we see this as a positive evolution, and we're looking at the application of this tool to other assets such as street lighting and safety barriers. So all in all, for us, it leads us to sort of moving Hertfordshire forward, ensuring safe, reliable, sustainable and smart travel. Thank you.